In this series of SGEMS tutorials, I'll be explaining some features and functionalities of the SGEMS, and particularly those that pertain to the material we cover in the course GS 240, Data Science for Geoscience. I refer to the SGEMS book, of course, which can be purchased from Cambridge University Press. It's called Applied Geostatistics with SGEMS. A lot of the material that is in there is also derived from the book Geostatistics for Natural Resource Evaluation by Pierre Gouvarts. And there are also some multi-point geostatistics tools, of which you will find a reference as well here on the right. In the first part, we'll just do some introductory material on just giving a basic overview, how to load data, how to save a SGEMS project, and how to do some exploratory data analysis. Okay, so here I have a folder with two data sets. One is an exhaustive data on a regular grid, the other is a point set. So if you open these files, the exhaustive set is on a regular grid, and the grid size here is 70 by 70 by 18. That means that we have here a column that has as many values in it as this dimension. So I refer to the SGEMS book in terms of, and also the GSLib book in terms of the conventions on how this is stored. But essentially what it does is that it cycles the X columns first, then the Y columns, and then the Z columns. So basically it stores things based on a Cartesian axis system. So we can just load by either using objects load object, or we could just drag the whole thing in here and we get the same file, as you notice. So we are dealing with a Cartesian grid. So I'm going to name that SkyTem data. This is our geophysical data in this particular example. And so then the number of cells, I enter those, which were 70 by 70 by 18. I suggest that we leave this alone for now. You can also use no data value. I suggest also for working in SGEMS is that you just transform everything into a grid cell size of 1, so we don't have to bother with having actual coordinates. So once we have that, we finish, and then we notice that our object is loaded. We can click through this, and then we get a grid on which we have our data. So in SGEMS, you can then work around with this and check this out. Okay, there's some other features here that gives different views. You can also center, for example, you could have done that. And so if you want to go back to that, you just center the view. Okay, so we can do a couple of other things with this object. We can go to preferences, select that data set, and then we can use, for example, what is useful here is the volume explorer. For example, do hide volume, use volume explorer, and then I can select various sections for viewing, and I can add more sections for viewing, etc. So this gives you a good idea of how you can look inside, outside. Zooming can be done with scrolling with the mouse, etc. The general preferences are useful as well. You don't like the black background, it's a bit morbid for you, so you could just use a white background. We can add a color bar to it. I have to look at that. You can also scale things, show color bar off. For example, our SkyTem data, and then see the coordinates, the values of the resistivity. Okay, so then we have a second type of data that you can enter, and these are point sets. So point sets, we actually provide the X, Y, Z coordinate, which would be the first three numbers here. And then we have, in this particular case, we have three properties, which is lithology, porosity, and resistivity, and they follow just after. So lithology here is just done by an indicator or just a categorical value. So 1, 2, 3 or 0, 1, 2. It doesn't really matter. So loading that is the same way. We put that here. Then we have to be careful and select here point set. You go to next. So let's call that our well data. We have here coordinates for X column and Y column. That's what we saw in the previous file. And we select now the third column. We can see that here the third column is our Z coordinate. Okay, we finish. So we get a new data set here, objects, which we can look at. So here now we see that we have loaded several of these wells, which has a lithology, porosity, and resistivity at those locations. Another way of doing the same thing is we can then save this project if you like to. Save a project, then you'll get a file like we see here on the left-hand side. We're not going to do that. We're just going to close. Don't save. We have everything empty. So if you had saved the project previously, then you would have a file like this that says .project, and then you can just drag that over here, and you get the same thing. Okay, so this is some basic ideas. For data analysis, we can do some basic EDA. For example, you may want to plot the porosity of wells, histogram, and then you get the histogram of porosity, which has then some information about summary statistics. That's one thing. The other thing is you can make QQ plots comparing histograms. So I'd like to compare, for example, the SkyTem resistivity with the well resistivity. Click through that, and then you notice that that looks like it's a nice comparison. That you get a pretty much 45-degree line, which says these resistivities have a similar histogram. And that's also noticed here in here. Final thing is we can make scatter plots, which is the same thing. It's not the same thing. It's just comparing, it's looking for correlations. For example, I would like to know the correlation between porosity and resistivity, and then I notice this. So what I notice is, of course, you have two populations. In this particular case, has to do with being in the buried valley, which has a higher porosity and resistivity than being not in the buried valley. So we get this kind of kink here. Overall correlation is 0.8